Hello everyone. So welcome to my channel. So today we are going to discuss about subnetting. So subnetting is a very important concept in computer networks because uh, uh, we know IP addresses is very important entity in internet or any communication networks. So we have huge number of networks, right? Huge number of networks and devices. So in order to connect all the uh, devices into the network or internet, we need IP address, right? We need IP address. So IP address, there are two types of IP addresses: IPv4 and IPv6, right? So still we are using IPv4. So every device needs to acquire a unique IP address in order to communicate to the network or any other device which is present in the network, right, or internet, right? So whether it is class A or B or C, right? Uh, there is a restriction in connecting the number of devices, right? Say, for example, in class C, you can connect only 256 numbers of computers, laptops, or desktops, whatever it is, right? So you can accommodate only 256 devices in class C network, right? Class C network. So as we know, uh, uh, IP address consists of two components, right? It's a 32-bit address. IPv4 is 32-bit address, right? And each 8 bits are separated by a dot, right? Each 8 bits are separated by a dot. So it is also called as dotted decimal notation. The other name of IP address is also called as dotted decimal notation, right? So each 8 bits are separated by dot, and those 8 bits are represented by decimal numbers, right? Decimal numbers or decimal numbers. So that's why we used to call it as dotted decimal notations, right? And it consists of two important parts. Two parts are there in the IP address, right? So one is net ID, right? Another one is host ID, right? So there are two parts. So 32 bits are divided into two parts: net ID and host ID, right? So with this basic introduction, let us get into the subnetting. So subnetting is a type of hierarchical addressing scheme, right? So the concept of subnetting is to divide a large network into a number of small subnetworks, right? Say, for example, uh, um, if you have a business, right, running in multiple geographical locations of a city or state, right? Four branches are there, say for example, right? If you want to divide the IP address, so you have acquired only one IP address, public IP address, so which needs to be divided into four branches, right? Four branches. Otherwise, if you don't have subnetting, right, you have to acquire four public IP address for each branch, right? Four public IP address for each branch, but subnetting with subnetting, you can divide this public IP address for all the four branches, right? How? That is why we will discuss in this tutorial. See, subnetting creates an intermediate level of hierarchy. So the basic idea is to divide the large network into smaller subnetworks, right? So, uh, usually the IP packets or datagrams will be delivered in three steps, right? Three steps. That's why I was here mentioned. First, it will be delivered to the site, right? Site, and then delivered to the subnetwork, and then delivered to the host, intended host, right? So, as I told you, it consists of two components: net ID and host ID, right? So, what we are going to do is we are going to borrow a device, sorry, borrow a bit, right? We are going to borrow a bit from the host ID component, right? So as we discussed, there are two parts, net ID and host ID. uh, we are going to borrow uh, 1 bit or 2 bits, 3 bits, whatever, right? It depends upon our requirement, right? So if you borrow 1 bit, you can accommodate two, 2 power, right? 2 power 1 is equal to 2. So you can have two subnets, right? Whereas if you are borrowing 2 bits from the host ID part, then you can accommodate or you can have 4 subnets, right? 4 subnets. So this is how the process will go. So everything will be calculated in terms of 2 power n, right? So if you are borrowing 1 bit, 2 power 1 is equal to 2, 2 power 2 is equal to 4, 2 power 3 is equal to 8. Likewise, the subnets and the host part will be, right? So here is the simple example. See, class A, first byte will be used to represent the net ID. The remaining 3 bytes will be used to represent host ID, right? So this is your net ID in decimal notation, right? Whereas class B, 2 bytes will be for net ID and 2 bytes will be for host ID, right? For class A, 3 bytes will be used for net ID and only 1 byte will be used for host ID, right? So this is just to remember the concept of IP addresses. So subnetting uh, uh, is nothing but, see, we are borrowing uh, a bit from the host ID part, right? So how do we calculate the network address from the IP address? See, it's very simple. See here, this is your given IP address, right? So in order to calculate the network address or IP address, you have to convert the decimal notation to binary notation, right? Then subnet mask uh, will also be considered in the binary notation. So you have to do a logical AND operation. See, you have to do a logical AND operation between the IP address and subnet mask. Then the resulting values, binary values, will be converted to decimal for the final network address, right? So this is the basic concept of subnetting, right? So this is your default subnet mask for class A. The default subnet mask is 255.0.0.0 because as we remember, the network components, the network parts are always enabled, right? The network parts are always enabled, which means you cannot change the network components part, right? So you cannot change the network component part, uh, right? So you cannot change the network components part. See, for class A, right? For class A, uh, the first 8 bits are always enabled, right? First 8 bits are always enabled, so which cannot be altered, right? So the value of the network part is 255, right? That means 1 into 2 power 0, 2 power 1, 2 power 2, 2 power 3, and 2 power 7. So if you add all these values together, the resulting will be 255. So the default subnet mask for class A IP address is 255.0.0.0, right? Similarly, for class B, the default subnet mask is 255.255.0.0, and for class C is 255.255.0, right? So masking, as I told you, extract the IP address of the physical network from an IP address. How? You have to do a logical AND operation. So first you have to convert this IP address and subnet mask into binary notation. Then you have to do a logical AND operation in order to calculate the physical network address. So this is the basic idea of mask, right? So here is a simple example how to calculate the subnet ID, right? Subnet ID for this network, right? So this is the given IP address 192.168.10.35, which will be converted to binary notation, right? So the binary notation is 111000000, right? And this is the binary notation for 168. and this is the binary notation for 10, and this is the binary notation for 30, right? And subnet mask will also be converted to binary format, and then you have to do a logical AND operation. Simple, right? So 1, 1, 1. So 1, 1, 1, 1, 1, 1, because you have a carry here. So you need to refine the result, write the final result with the carry, right? 0, 1, 0, right? You know the AND operation, right? So if both the inputs are the same, right, the output is also same, right? If both the inputs are different, output will be 0, right? If both the inputs are 1, the output will be 1, right? If both the inputs are different, the output value will be 0, right? So this is your AND operation, and then the binary values will be converted back to decimal format. So the resulting value will be the subnet ID value, right? Subnet ID value. I hope you have understand the basics of subnetting. Subnetting is very, very important because we need subnetting because if you acquire a IP address without subnetting, right? Most of the IP addresses would be wasted, right? Or it's not properly utilized. So in order to utilize the IP addresses effectively, uh, we need subnetting, right? So we'll discuss subnetting in detail in the upcoming lectures. Thank you.